Assistant Professor in SNS College of Technology from ECE Department. Today we are going to discuss the basic concept of electrical circuits in the subject of fundamentals of electrical and electronics engineering. If you are a beginner or revising for exam, this video will make the things super easy to understand. Let's get started. Today we are going to discuss what is electricity, what are the sources to generate electricity, and then voltage, current and resistance. Next, finally, the nature of current. The current can be divided into two types. Current can be divided into two types, a DC current and then AC current. Move on to how the electricity comes from. Electricity, what is electricity? Electricity is nothing but a form of energy that we can use every single day to light up our fans, homes and charge our phones and so on. But where does this electricity comes from? Can you imagine without electricity we can live? No. There are so many sources of electricity generation happens. We can buy it from our power plants, like a hydropower plants which uses flowing water to generate a power. We can generate it ourselves using a diesel or a gasoline generator, or even through the solar panel or a wind turbine. Cars also generate electricity through the alternators. Sometimes nature also generate electricity in the form of lightning. So electricity comes from many different sources. Let us talk about the three important concepts in any electrical circuit is a voltage, current and then resistance. First, what is voltage? Voltage is a pressure that pushes electric charge through the wire. You can think of it as a force that makes the current flow. It's measured in volt. We compare electricity to water flowing in a pipe. The voltage is like a water pressure that pushes the water forward. So higher the voltage, stronger the push. Next, move on to current. Now current is flow of electric charge, just like a flow of water in a pipe. It tells us how the electricity is flowing and measured in amperes or simply amps. Current is a flow of electrons through the conductor like a wire. So voltage pushes, the current flows. Next, move on to resistance. The next one, resistance is the name implies it resists or opposes the flow of current, is measured in ohms. If voltage is pushed or a current is flow, the resistance is a blocker. It's like a narrow pipe that makes harder for the water to come. All the material having some resistance value. For example, copper has a low resistance, rubber has a high resistance value. If it a low resistance value means the flow of the electron flow happens in easy. If it is a high resistance value, the flow of electrons it's a hard to it opposes the flow of electrons. This chart gives the relationship between the voltage, current and then resistance value. It's a very famous law that connect all the three, voltage, current and the resistance. We call it as a Ohm's law. Ohm's law equal to V equal to I into R. Next, move on to nature of current. There are the two type of current, direct current and then alternating current. Most power in our homes is alternating current, but our gadgets like a phone, laptop uses DC. In laboratories also we are using a DC power. Let us see the difference between the AC and the DC. The DC stands for a direct current. So the current flow only one direction. It does not change with the time. We use the DC in a batteries, power supplies, laptop, laptop, even in a solar panel. The best thing is easy to store in batteries, but when we need a AC power, we use a device called an inverter. Inverter. It convert the DC to AC. Next, move on to AC circuits. AC current is easier to distribute. AC is nothing but an alternating current. So, it keeps changing the direction. It goes positive and then negative in repetitive pattern. It, it changes with respect to time. Its magnitude and direction changes with periodical manner. If you could see in a graph, it's like a waveform. It's called a sinusoidal wave. So AC is used because it's easier to distribute over a long distance, and also the losses and also without losing much power. So the electricity in our homes, light and machines all run on a AC. Meanwhile, most electronics are converted AC to DC internally using the power supplies. Power supply. Let's quickly recap. What is electricity? It comes from many sources. And then what is voltage? It's a push or pressure that drives the current. Then Ohm's law, it states that V equal to I into R. DC current flows only in one direction using a batteries and electronics and electronic power supply. The AC keeps changing and direction used in homes and industries. Simple and powerful concept. These are the simple and powerful concepts that come from the basis of electrical engineering. Thank you all. We will meet in another one session. Thank you all.